and welcome back to the second video of our collection framework playlist. In this video, we're gonna talk about one of the core concepts of Java collection framework, the collection interface. So let's take into it. Well, let's start with the definition of collection. Simply put, it represents a group of objects or elements and defines a set of methods for working with those elements. Here, group of objects or elements refer to a group of integers, string, or custom objects. So, this is a collection, but isn't it an array? Well, yes. Does this mean collection and array are same? Well, the answer to this question is yes and no both. Let me explain it to you. So the thing is, if this is an array, then this is a collection. See, whenever we declare an array, we always do a static memory allocation. Here, static memory allocation refers to a fixed memory size. So, whenever we use an array, we have to mention the size of the array while declaration. But the case with collection is different. We can declare a collection with a static memory allocation. In addition to it, we can even declare a collection with dynamic memory allocation. Here, dynamic memory allocation refers to a variable memory size. Let's understand the concept of static memory allocation and dynamic memory allocation. Consider 5 guests are coming to your house and you need to arrange chairs for them. Now, if you use static memory allocation, then you will bring all the chairs at once. But if you use dynamic memory allocation, then when guest 1 enters your house, you bring the first chair, then as guest 2 enters, you bring another chair, then the third guest enters, you bring another chair, then fourth guest enters, you bring another chair, and then the fifth guest enters, you bring another chair. So in this manner, static and dynamic memory allocation works. While using static memory allocation, you must know the total space you need, which is definitely an overhead. But with dynamic memory allocation, if you need the memory, it will be allocated to you. That's simply straightforward. Now consider two cases. Case 1, when all the 5 guests comes to your house. In the scenario of static memory, it will allocate 5 chairs beforehand and all the chairs will get filled by the guest one by one. And in the case of dynamic memory allocation, as a guest comes, it allocates a chair to the guest, and when another guest comes, it allocates another chair to the guest. And in this fashion, dynamic memory allocation will also fill all the 5 chairs. Thus, no memory wastage in case 1. Now case 2, when only 3 out of 5 guests comes to your house. In the scenario of static memory, it will allocate 5 chairs beforehand. However, 2 chairs will remain vacant. But in the case of dynamic memory allocation, as guest 1 comes, it allocates first chair to the guest, then guest 2 comes, it allocates another chair to the guest, and then guest 3 comes, it allocates another chair to the guest. Now, no further guest is coming, so it will not allocate any chairs further. Thus, no vacant chairs and efficient utilization of the space. Now if you can relate guest as data element and chairs as memory space, it will become crystal clear to you which memory allocation method is ideal for you. So collection is just like an array, more of a advanced version of array, which is very efficient and have more functionalities. That's why I said, if this is an array, then this is a collection. Hope the difference between an array and a collection is clear now. Java provides several types of collections such as list, example array list, linked list, set, example hash set, tree set, map, example hash map, tree map, queue, example linked list, priority queue, and stack. These are just some of the most commonly used types of collections in Java. There are many other specialized collection classes and interfaces available in Java that can be used for specific use cases. We will learn about them in details in the coming videos. Now, let's take a closer look at some of the methods in the collection interface. Adding and removing elements. The collection interface provides several methods for adding and removing elements from a collection. Add, object O, adds the specified element to the collection. Add all, collection C, adds all of the elements in the specified collection to the collection. Remove object O, removes the specified element from the collection. Remove all, collection C, removes all of the elements in the specified collection from the collection. Clear, removes all elements from the collection. Querying the collection. The collection interface also provides methods for querying the collection and retrieving information about its element. Size returns the number of elements in the collection is empty. Returns true if the collection contains no elements. Contains object O. Returns true if the collection contains the specified element. Contains all, collection C, returns true if the collection contains all of the element in the specified collection. Iterating over the collection. Another key feature of the collection interface is its ability to iterate over its elements. Iterator returns an iterator over the elements in the collection for each consumer super action. Performs the specified action on each element in the collection. Stream returns a sequential stream with the elements of the collection as its source. Converting the collection. The collection interface also provides methods for converting the collection to other types. ToArray returns an array containing all of the elements in the collection. ToArray TA returns an array containing all of the elements in the collection using the specified array if it is large enough. Modifying the collection. Finally, the collection interface includes methods for modifying the collection. Retain all, collection C, removes all elements from the collection that are not in the specified collection. Remove LF, predicate super E filter, removes all elements from the collection that satisfy the specified predicate. Replace all, unary operator E operator, replaces each elements in the collection with the result of applying the specified operator to that element. Overall, the collection interface is a powerful tool for working with collections in Java. By providing a standard set of methods for working with collections, the interface enables interoperability between different collection types and simplifies the process of working with groups of related objects. Well, that's it for this video. In the next video, we will take a closer look at list interface and we will do hands-on implementation of collection methods over ArrayList. Thanks for watching.